Okay, how do we use a canonical pendulum to explain uniform circular motion? To be precise, horizontal uniform circular motion. Now, there's it here. Don't forget we are deriving formulas on this. So we talk about canonical pendulum. Now, there's it as more or less like the normal pendulum, but look at what it looks like. This a canonical pendulum. We have this here. We have the bulb, pendulum bulb at this very junction, being connected to this place. Now the pendulum is being weird like this. It moves in this circle, goes this way. The pendulum goes this way, just like this. It's weird like this. Now you have something like this. There's a radius of the circle here. Now don't forget this is a string. The string L, the string makes an angle of theta with a vertical. So this pendulum here has a weight, a downward weight. Weight is mass and gravity. Look at this. This weight is a kind of force also. So the weight is mass and gravity, while there's the length of the string of the pendulum. So the pendulum oscillates like this in what we call horizontal cycle. Don't forget, the canonical circle talks about canonical pendulum, I beg your pardon, talks about horizontal circular motion. So it's horizontal circle. So now what are we going to do here? We are going to derive various formulas on this in case we see questions on this. So now there's it here. We have the length of the very string. Y here is the radius of the very circle. So don't forget the string. There's a tension in this string. There's a tension. Now the question is, what brings about the circular motion? Now don't forget something. For horizontal circular motion, gravity is not really involved. Although we have force of gravity actually, but gravity is parallel. I mean, not perpendicular. Gravity is parallel to this, so the force of gravity does not really have any relationship or does not play any role in the circular motion. What brings about the centripetal force here, that is the force that keeps this body moving in a circular path, is the tension in this very string. It's a tension. It's a tension that makes this body to keep oscillating. It's not gravity. So now, how do we explain that? We're going to explain that, and also we're going to derive formulas for this. So first of all, you have a tension here. The tension is going to, since this is an angular motion, the tension will be resolved in 2 dimensions. So first of all, we have the tension like this. This tension. We need the help of trigonometry here. You have to have the basic knowledge of trigonometry, trig ratio. So we have an angle here, theta. So we have a force, the tensional force, this Ft is the tensional force. The tensional force along x-axis, the tensional force along y-axis. And for the fact that the tension is facing up like this, the component to be resolved in these 2 components like this